All right. Good afternoon. All right. Come on. Good afternoon. Much better. Like it. How's day one been so far? Very nice. Can you tell that I'm also a spin instructor and I'm ready for some like woos and some yells? Okay. Yeah, I know, right? Welcome. We're here to talk about QueryStore and automatic tuning in SQL Server. So some of the stuff that Bob and Connor showed this morning, if you were in the keynote, they kind of zipped through that. We'll spend a little bit more time talking about it. These are slides you'll see often, so I'm going to roll through them pretty quickly. While you're here this week, make sure that you take advantage of everything that PASS has to offer. If this is your first experience with PASS as an organization, welcome to Summit. And there is a lot that you can do this week, and there's a lot that you can learn about. So if you've got questions, feel free to come up and ask me after the session, or feel free to tap into anybody who's not a first-timer. Session evaluation, something you can complete online only. Please do these. I recommend doing them throughout the day after each session. If you wait till next Friday, which is when they have to be done, you'll probably have forgotten a lot by then. This is my yay me slide. I'm Erin Stellato. The most important thing on here is my email address, erin@sqlskills.com. If you've got any questions related to this session after the fact, please feel free to email me. I'd encourage you to ask questions while we're here. We'll take them as time permits. And by we, I mean me and...
And hi, everyone. My name is Dan. I'm a software engineer in Microsoft and one of the developers of this cool feature, QueryStore, and also auto-tuning that we're about to present you today. And also my email is on the slide, so feel free to send any questions you might have to me. Thanks.
Yep. So we've been talking for the past several months about QueryStore, and we were able to time the trip so that we could both be here today to talk about QueryStore. This is the abstract. I'm not going to read it to you. I assume that you've already read it. I just like to throw it up here to make sure that you're in the right room. We've got 75 minutes to talk about a lot of cool functionality within SQL Server, starting with QueryStore and walking through to automatic tuning. So here's our plan. Some basics related to the QueryStore feature. We'll talk about the new addition of weight statistics in QueryStore, which is specific to SQL Server 2017. We'll talk about plan forcing, and then we'll finish up with automatic plan correction. So in terms of QueryStore and what it is, how many of you are actually running SQL Server 2016 or higher? Love it.
Great.
Okay, that's fabulous. Of those of you who are running 2016, how many of you are using QueryStore? That's pretty good. I like it. All right. So for those of you that are already using it, this will be a little bit of a review. But for those of you who haven't used it, who haven't really explored, QueryStore was built as a flight data recorder. So if you look at any of the initial documentation that was released, flight data recorder is in there very frequently. And if you think about an airplane, right? The airplane has that black box. And when the unfortunate incident of an airplane going down occurs, they're immediately looking for that black box, right? They want to understand what happened. And that's what they go to get that information. In SQL Server, that's what QueryStore can now provide to you, because historically, when you've got an issue with SQL Server, what's one of the things that people sometimes do to resolve that issue? It takes all your data away. They restart, right? Let me just restart it. Problem goes away, I'm good. But how do you do any root cause analysis at that point? Because all of the data, the majority of data is gone. You still have your health session, you still got the default trace, you still got the error log, but all that great information that was in the DMVs is gone. So this is what gets added into QueryStore. We're getting information about query execution, which means that we get query text, we get query plan, and we get runtime statistics. And I'll say execution statistics and runtime statistics interchangeably. One of my favorite things about QueryStore, it's available in every edition of SQL Server, right? It's not specific to Enterprise. It's available actually in Express. I highly recommend that you run the latest version. That's a traditional recommendation that SQL Skills has across the board. We'd like to see you on the latest Service Pack or CU. With regard to QueryStore, there was a bug that was fixed in Service Pack 1 specific to Standard Edition and Express Edition. So if you're on 2016, I definitely want to see you on at least Service Pack 1, ideally CU5, which is current, CU2 at a minimum because of another bug that was fixed there. If you're running 2017, CU1 just came out last week. I'd recommend patching up to that as well. Now, who should use QueryStore? This was one of our initial conversations that we had about using it, because as somebody who's worked with query tuning and troubleshooting for a long time, I was excited because of all the information it captured and what I could do with that information in a myriad of ways. But you do not need to be a query tuning expert in order to use QueryStore. It was designed for a data professional who has access to QueryStore, who can look at data to be able to go in and figure out what's going on. If you are an expert at performance tuning, you don't have to wear glasses, right? I'm not saying that this is what you look like, but this was kind of the nerdy look that I was going for. If you are familiar with query tuning, QueryStore is something that you're going to look at and you're going to immediately recognize what you can do with it and the advantages that it gives to you, and then you're going to start thinking of what else you can do with that.
Yeah, so QueryStore will actually help both of these groups to leverage the most out of the data that is there over time. So, and one of the interesting points, I just want to return to previous slide just to showcase this last sentence, that QueryStore is enabled by default in Azure SQL database. So what this means is that for every user database, and there's currently around 2 million of them on Azure SQL database, QueryStore is up and running. So those are various queues, various editions, standard, premium, basic. And this approach is actually the one that helped us learn about the data because of all the telemetry that's available on SQL Azure and integrate these learnings back into QueryStore when we actually released it in SQL 2016 and then further improved it in SQL 2017. So the end product you're getting in on-premise SQL Server is iteratively an improved version on SQL Azure that we had the chance to test and iron out and run on various workloads.
Right, so of those 2 million or so databases in Azure, there's only, what was it, I think it was like 50,000 or something that have turned QueryStore off for some reason or other. So Rohan mentioned this morning the significant amount of telemetry that gets captured, right, every single day. That includes telemetry data related to QueryStore. So some details about QueryStore in terms of what you need to know for how it's going to be implemented. It's enabled at the database level, and it is not enabled by default in on-premises. So if you install 2016, 2017, you upgrade a user database, by default, QueryStore is not enabled. You have to go and enable that per user database. You can enable it for one system database, that's MSDB. I have yet to figure out a reason for doing so, but I'm certain that somebody can find an edge case for me. But that's the only system database. Otherwise, it's user database. That data, the QueryStore data that gets captured, is persisted in tables internal to that user database. Those are system tables. They're exposed to you through catalog views. They're located in the primary file group. That means that every time you do a backup and restore, like to your test environment, because I know you all have one, or to dev or to QA, that QueryStore data comes with it. So again, cannot be enabled for model, for master, for tempdb. You can enable it for MSDB. In order to look at that QueryStore data, you have to have the view database state permission. So depending on who has access to your system, if you've got multiple DBAs, you've got junior DBAs, you've got developers, if you just want to let them see the data, view database state. If you want to give them the power to force and unforce plans, which is a power, in my opinion, they have to be DB owner, right? That's a higher level permission because forcing the plan really kind of understands a little bit about the impact that that's going to have on the system overall. And the data related to QueryStore is something you can view in Management Studio using the different reports that are available there, or you can query those catalog views directly to interrogate that information.
So just for reference, how many of you did actually use SSMS QueryStore UI reports? Well, that's really cool.
How many of you write your own T-SQL? Ah, yeah. Okay, now in terms of the data that we've talked about, that we know about historically in SQL Server when we're talking about capturing text and plan and runtime stats. If we think about the query and the text, then we're looking at DMExec query plan, DMExec cache plans, and DMExec SQL text. That information in QueryStore is stored in an area called the plan store. And there's no differentiation really, it's just a logical way to kind of group that information. If we're talking about the exec query stats, or the type of information that we might pull from statement completed events in extended events or trace, that is stored in the runtime stats stored. And again, you'll hear me say execution stats, runtime stats interchangeably. We also have wait statistics. And this would be analogous to what we would pull from DMExec session wait stats, but it's specific to a plan. That gets stored in the wait stats store. And again, the wait stats information is specific to SQL Server 2017 and Azure SQL Database. So if you're on 2016, you're not going to see the wait stats, and there's no plans to port that back.
Nope.
So if we look at the data that actually gets captured, within the plan store itself, we have the text of the query, and textual matching is still in effect here. So individual queries are captured. If I've got a stored procedure that has multiple queries, 10, 15, 100 queries, all those queries are captured individually, as well as the plan or plans. Right? Every variation for a query, every plan that you might have is tied to that particular query. That's captured as well. In terms of the runtime stats, these are tied to the plan. So how frequently has that plan been used, right? What is the count? What do we have in terms of duration, logical I/O, physical I/O, writes, CPU? In 2017, we also get things like log bytes used and tempdb used. Again, not in 2016, only in 2017. And again, that is per plan, and that is over a period of time. And then we've got our wait stats store, which is the wait stats information grouped by plan over time.
If there are any questions, feel free to ask them at any point.
Yeah, you should feel free to interrupt. I have kids. I'm used to people interrupting me all the time. Yeah. So what's the anticipated growth? What's the anticipated size of my QueryStore data when I enable it? OK, so I want you to think about this. I'm telling you that it captures text, and it captures plans, and it captures, it respects ad hoc queries as separate queries, right? Textual matching is in effect, so if I have select star from person and select star from space person, extra space, lowercase, right? Those are different queries. So now think about your workload. What kind of workload do you have? A lot of stored procedures? A lot of ad hoc queries? What is it? Both. You're a fun one, OK? So I'm sure you're fun anyway. It's not just your workload, right? But if I have a lot of stored procedures where I don't have a ton of variability in my queries, then the queries that are in there are pretty consistent. And maybe I've got crazy variability in my plans. That's always a possibility. Right? But those are some of the factors right there. What does my workload look like? How many different queries, unique queries do I have? And how many different plans do I then have? And you're probably thinking where you're going next is, well, how much space do I need? Right? Is that what you're thinking? Right? It depends. It depends on that. Depends on your workload. It also depends on how long you want to keep information, because by default, it's keeping information for 30 days. If you're the kind of shop that likes to develop in production, you don't have to admit it to me, but you might want to keep some of that data a little bit longer. If you're really controlled about pushing out code changes and there's not a ton of variability, then maybe 30 days is fine for you. But the more data that I'm going to keep, the more space that I'm going to need. The other factor that comes into play is my intervals. So one of the things that you specify is across what intervals do I want those runtime statistics to be captured. And by default, it's every 60 minutes. So think about snapshotting DMExec query stats at 2 o'clock and then again at 3 o'clock and diffing that, right? That window, that aggregated set of data about query execution, that's an interval, right? And you can configure those intervals in QueryStore. Default is 60 minutes. Maybe you want it to be a little more granular. Maybe you want 30-minute intervals, or maybe you want 15-minute intervals. The smaller those intervals, the more data you're going to have as well. So I have a customer that has a 1.5 terabyte database that has a crazy workload, a lot of ad hoc queries. I keep that data for 30 days. I have the intervals set to 30 minutes, and that query store is 4 gigs in size. Now, of that query store, 3 gigs of that is plans, right? So those plans can take up a significant amount of space. Now, there's other databases that are about 100 gigs that have QueryStore enabled, less than a gig total.
So, and one important point to keep in mind, if you think about data that is stored in QueryStore, showplan XML is the largest piece of data, but QueryStore actually internally compresses these plans, so the actual space used by these plans is 2 orders of magnitude lower than it would be, then they were not compressed. So that's one point. And the other point, the default value for storage size, upper limit is 100 megabytes, but on Azure SQL databases for premium editions, which are a bit higher SKUs, we use 1 gigabyte default, and it's pretty well set limit for most of the database, and we don't know of any case that what Erin said, like over 4 or 5 gigabytes, that it's not enough with all these cleanup and retention policies that periodically clean all data. So that should be more than enough.
All right. So in talking about QueryStore, we talk about the database and those tables that exist within the database that store that user data. Mickey, yeah.
Question?
So I think your question is if I have optimized for ad hoc workload enabled or if I have a recompile on my query, right? With optimized for ad hoc workload, the initial query execution just puts a query stub into the plan cache, which is usually like 3 bytes in size, way smaller than the regular plan. If I have a recompile, that plan doesn't go into cache. That's cache. That's not QueryStore, right? So when the query executes, the query text goes in there and the plan goes in there, whether or not I have optimized for ad hoc enabled, whether or not I have a recompile on there. So it goes into plan. It's also the estimated plan, right? The same plan that's in cache, which is the plan that gets used, that has just the estimates in it. That's the plan that's also in QueryStore.
There's a question over there.
Yep. Yes, those last 2 options, log bytes used in TempDB, I have asterisks next to them because those are specific to 2017. All right, so in terms of how this data gets into QueryStore, because if you start thinking about this, some of you might have thought already, this is a question I get a lot, what's the performance impact of this? You're telling me that you're writing this data to tables in my user database, and you're telling me you're capturing query text and plan and runtime statistics so that every time a query executes, you're putting information into this database. Yes, but here's how it goes. So we have plan store, we have runtime stat store, and we have the wait time stat store, right? These different just kind of logical ways of grouping that data. You execute a query. Query goes through compilation if it's needed, it goes through execution. After the query's been optimized, compiled, before it executes, that plan, that text, those are sent over to QueryStore at that point. Once the query finishes executing, then the runtime stats for that query are sent over to QueryStore. But there's a component here that I haven't mentioned, which is that data is stored in memory structures, not in memory OLTP objects, but they're different in-memory structures that are holding that information, and on a regular basis, it gets asynchronously flushed down to disk. So this is a performance optimization, right? Because if I tried to write all that information exactly as it was occurring, I have a lot of I/O that I'm creating. Rather, that information is getting held in memory, and it's getting pushed out to disk on a regular basis. Yes? I'm sorry, can I have you speak up a little bit? How does it affect the in-memory wait stores with the buffer manager? So it's different memory clerks. So there are separate memory clerks that exist for QueryStore. There's five different memory clerks that exist that are storing different information, separate from plan cache buffer pool information. Yeah? Uh-huh. Describe what you... Mm-hmm. So if it was not flushed to disk prior to the failover, then you would have lost that information. But on a shutdown, there is a process to go through to flush information out to disk before the shutdown of the SQL Server occurs, right?
And to your point, like there's a background task that does flush to disk every 15 minutes. So in theory, you should lose only up to 15 minutes of your data on a failover.
And that's a setting that you can configure also. You can, yeah. There is a system store procedure that you can execute to flush it. So if you're going to shut down manually for whatever reason, you can always run that manual store procedure, flush the data to disk, and fail over that way. Note that if you do have an availability group, because this one's coming, so I'm just going to throw it out there now. If you do have an availability group, the question we get asked is, okay, I've got my primary, which is read-write. I'm executing the queries. QueryStore is over here, right? Data's getting moved over to my replica. What about the queries on the replica? Those aren't being captured by QueryStore because that's a read-only copy of the database. Questions about that? I'm going to dash those hopes and dreams right now. So the question is, this has query hash information, which the query hash does go into QueryStore. Do I get any information about who executed it, from where it was executed, et cetera? No. Are you going to add that?
No, like that's one of the possible future extensions. Currently, you have only query parameters such as query hash, ID, context setting, stuff like that, but not the source of execution.
All right, so do you want to see what it looks like if you haven't seen it? Yeah. Oh, one more question. So the question is, separate from storing it in the primary, are there any plans to be able to write the information when you're querying a secondary copy?
Yes, we have considered this, and it's in our medium-term plans. Like short-term, it will not happen, but medium-term, we're considering multiple options. One is to store into a separate user database out of readable secondary, not to break read-only structures, but this is still to be determined. This is definitely something we're thinking about solving because it's actual user scenario.
Are you also considering having QueryStore for the instance instead of database?
So the question is, are you also considering having QueryStore enabled at the instance level?
So you're saying if you have multiple databases on instance, do we aggregate data for all the for the same queries on different databases, right? So. You can configure, I mean, there's tools to do this, and on Azure we have this mechanism to do this in a centralized telemetry repositorium. Within SQL Server Engine, currently there's no plans to do this, but you can easily write your own views that could, iterate over a database and fetch the data.
All right, so I want to drop into a demo, because if you haven't seen QueryStore, you're probably wondering what the heck it looks like at this point. So if I expand my admin database that I have here, you'll notice that I don't have anything related to QueryStore, and that's because I don't have QueryStore enabled for this database. So you're not going to see that folder unless it's enabled. But here, for my first copy of Wide World Importers, you'll see that I do have it. So I've got a QueryStore folder, and if I expand that, I've got a set of 5 reports underneath there. Now, I am running SQL Server 2017 CU1, and I'm running Management Studio 17.3. There are actually 6 reports available. In 17.3, you see 5, but you can get all of them through a right-click option. You'll notice that we also have this View Regressed Queries. That'll be fixed in the next SSMS version. If you're running 17.1 or 17.2, you'll see all 6. If you're running a 16x Management Studio, you'll only see 4 reports. I highly recommend going to 17 so that you can see all that information. So what do we have here? I like to start with top resource consuming queries. This tells me what do I have going on right now in the system. So in the top left, we've got a graph, a bar graph, right, that gives us the different queries that we have. And if I click on the queries, you'll notice that on the right, I've got information about performance, and that's specific to plans. So as I'm highlighting my different queries, right, we can see that I've got variations in performance. And I can highlight any of these queries, any of these dots, and that's going to give me the plan that's in use below. So let me see here. I've got the ability to create my DBCC free proc cache, not for production, right? Yeah. Now, the thing about this view is I've got to hover over the bar in order to see the query. And I tend to prefer to look at the grid format. So this button right here gives me the grid format, which will list the query text, makes it a little bit easier for me to see. So here, now I can look at an individual query, and if I scroll over to the right, one of the things that I really like about this view is I have this plan count. right? So how many times have you had the parameter-sensitive query or the query where the plan changes all of a sudden and you're trying to find that? So when we look at our top resource-consuming queries, I can go ahead and I can say, all right, what are my plans, or what are my queries that have multiple plans? And within this view, I definitely have options for configuration. So here, I've got this stored procedure, and I have this particular query within my stored procedure, and I've got two different plans, a plan ID of 701 and a plan ID of 3. So if I click on this one, I can see that this is a clustered index scan, whereas my other one has an index seek with the key lookup, right? Parameter-sensitive query. If I wanted to compare these two, just as a side note, I can click on both of those from here, and I can compare those plans next to each other, right? New functionality that's added in Management Studio, and so I can dive into them right from there. Now, when I'm looking at this view, I can change what resource is of interest to me. So by default, I'm looking at duration. But I could look at execution count, or CPU, or reads. And I can change whether I'm looking at total versus average, min, max, standard deviation. And I can change my interval, right? I'm showing last hour by default. If I was just jumping in to look at a performance issue, which had been going on for the last 15 minutes, I could change it to that. And I can get just that window of time instead. Yes? So the dots that we see on the graph on the right side are the performance metrics for that plan. If I actually want to see when the plan was compiled, then I would want to go into something like the system views underneath. So I have this QueryStore query, and by the way, you need to make sure you're in the context of the database. I don't know how many times I've run these against master and seen nothing. But if I go QueryStore query, and I'm just giving you just the straight outputs, nothing fancy or filtered or ordered, I've got a query ID, I've got context settings, which is pretty important and useful when I'm troubleshooting sometimes. And here I have compile time, execution information. I also have optimization information if I start to scroll over. All of that is stored in the views, but we're not seeing that in that graph because that's just giving me performance of that plan over time.
Execution.
Yeah.
So is each one of those dots, is that an execution of that plan?
So each one of these dots represents execution statistics for that plan for an interval of time. I mentioned those intervals of time, right? So if I execute a query once, then I have that execution stat for an interval of time, and that's it. But if I execute the query 5,000, 8,000 times, I don't have 8,000 statistics, individual execution stats, right? Those are aggregated for the window of time. So the collection interval in this graph is every 10 minutes. That's not what I would necessarily recommend for your production environment. Again, by default, it's 60. The smaller that window, the more data I'm going to have. And so you need to start, I would say, start with a recommendation, which is 60, and make that smaller if you find that you need it.
So the motivation behind this is obviously it's not possible to track performance per execution without compromising the performance. So we're aggregating per time intervals. By default, it is 1 hour, but you can lower the interval as down to 1 minute for troubleshooting. And one additional point I would like to stress here is that this particular view, top resource consuming queries, is actually underlining one of the key scenarios for QueryStore. It is focused on queries. It is not focused on the resource consumption, on the overall resource consumption of your workload. So if you're looking to QueryStore to see how much CPU is your instance spending or how many reads, writes, the QueryStore is not ideal choice, because it does have some queries that it does not track by design. It does have some filters, how it captures queries. So the focus of QueryStore is to get you data for the top, most important resource-consuming queries. And most often, those are the ones you really care about when doing performance troubleshooting, because optimizing them would actually improve your workload performance.
Right, so there is an option, there's an overall resource consumption. This is a small amount of data. Obviously, if I'm looking at that over an extended period of time, right, then I might be able to notice performance trends. But this doesn't replace, someone asked me that the other day, does this replace using a third-party monitoring tool? I don't think so. To me, it's an enhancement, right? I can still pull, and if you don't have a third-party tool, but you're using perfmon, you're using extended events, you're using the DMVs for other things, for holistic performance of the server, that information is still relevant and still useful to you.
And also what we've seen from the data on Azure SQL database, most of the workloads actually have 5, 10, 15 queries which stand out, which consume most of the resources, and you only actually care about optimizing them, at least in first. And maybe later when you optimize them, then you proceed with the other ones.
Right. One more question? Yep. I'm sorry, I can't hear you. Can you speak a little louder? You have to turn on the query store. You have to change that setting. So that's a setting that you configure within the options of the database. So again, by default in SQL Server 2016 and SQL Server 2017, that is not enabled when you create a new database or when you upgrade. If you want to enable it, you have to go to the properties of the database, and you now have QueryStore as an option, and you would change that to a read-write state to enable that. I'm sorry, what was that? Then you can change the settings, yeah. So at the point that you set it up, you can change the settings. If I wanted to change my collection interval to a different value, those are fixed values. You can't go and select like 3 minutes, right? It's 1, 5, 10, 15, 30, an hour, or 1 day. But if you wanted to change that later on, you could absolutely do that.
But if the question was whether these settings are persisted, yes, they survive.
Oh, yes, they do. Yes, they are persisted. Yep. So the question related to settings, I'm gonna push that to later. If we have time at the end, I'll come back and we'll talk about the different settings. There's a lot of stuff that I want to talk about, and I'm gonna have a blog post that's gonna talk about the 9 different settings that you can have, what the defaults are, and what considerations there are for changing them. Okay? Yeah, one more. So QueryStore is not tied to the compat mode. So regardless of what compat mode you're running in.
Actually, this is one of the key scenarios for QueryStore where we upgrade to a newer server version, run under older compat level, get all the performance data, increase the compat level to the latest one, get the new performance data, and see if there's any plan regressions. You can always use QueryStore to enforce the older, better plans. Right. Erin actually has a nice blog post around this.
All right, so as I said, the settings, there's a blog post that'll go live tomorrow that's going to talk about the different settings that are available. Most of the default values are good starting points. An exception, I would say, is size, right? On a box product, the default is 100 megs. You're probably going to want to up that a little bit higher. Things that you're going to want to consider when you're making those changes. Do I want to capture the entire workload or just relevant queries? How much space do I want QueryStore to use? How much data do I want to keep? How long do I want to keep that data around? And again, across what interval of time do I want those runtime stats to be aggregated? Now, weight statistics. One of the things that was most asked for after QueryStore was released was the addition of weight statistics information into that. So remember, just a quick primer, right? Wait means that whatever thread is executing has to wait for some particular resource. And waits are normal in SQL Server. Every system has waits. The key is understanding what your normal wait statistics are. So if a thread has to wait for a resource to be available, SQL Server tracks that. If I need to wait to read a page from disk into memory, you get a page IO latch wait. Right? If we're waiting for a lock to be released so that I can make a modification, you'll see that as a lock wait. And traditionally, when we think about looking at wait statistics, up until 2016, we were really looking at those at the instance level, right? DMOS wait stats. And that was an aggregate unless you had flushed that information for some reason, but it was an aggregate since the last restart. And so a lot of people probably were using third-party tools, or you're snapshotting, right, on a regular basis to understand what your weight statistics look like. I highly recommend this. This is where we always start when we are troubleshooting performance. Now, we also have DMOS waiting tasks. What's going on right now, right? Let me see what is waiting right now. If you've ever used Atom Mechanics SP Who is Active, anybody have that tool? Yes, right, great thing, right? That hits waiting tasks. Let me see what I'm waiting for right now. Now, in 2016, we got the addition of DMExec session wait stats, which gives us wait information for an active session. In QueryStore, we're going to get that wait statistics information for a plan, and we're going to get that over time because that plan has its runtime stats, which are by the interval, and those wait stats follow that same pattern. Now, there's over 900 different wait types in SQL Server. trying to track all of those separately in QueryStore becomes a little bit of prohibitive in terms of cost, in terms of overhead. So the decision was made to use the same methodology that CSS uses, which is let me group those weights into different categories. And the information that gets captured then is the category as well as how much time we've spent, a total, an average, min-max, and a standard deviation. Do you want to add anything before I go in?
Yeah, like that's the technical limitation. So we had to go down from 900 plus weight types to around 25 weight categories because otherwise it would not be feasible. The memory and CPU overhead would be much bigger. But another nice side effect of it, if you're not an expert on weight stats and weight types and have read all these books around weight types, this should come actually pretty neat because these weight categories are much more intuitive and user-friendly than the actual acronyms and names used for weight types. So weight categories are CPU, memory, parallelism, lock, instead of these that look a bit cumbersome and you need to be either an expert or to refer to some books online or some materials to figure out what is actually beneath it.
And the ones that are highlighted in red are actually the top weights for Azure. So I have that information as well.
And also this continues the trend and the main theme of QueryStore. If you look at the runtime stats that are tracked, CPU, memory, physical reads, logical reads, so most are pretty intuitive. You don't have to be performance troubleshooting expert to be able to consume this data. So weight stats and categories continue that trend, and you basically only need basic knowledge and of these terms to be able to consume this data and effectively use it to narrow down your performance problem within your workload.
Yep.
What's the negative impact on performance of capturing this information?
So what is the performance impact of capturing this information?
Okay, so if you remember on some of the previous slides, Erin pointed out that this is not really done synchronously on query execution, so everything is just captured in memory and then pushed asynchronously to disk. So the overhead is really minimal, and it actually also depends on your workload type. So if you have a workload with lots of different queries or lots of ad hoc queries and non-parameterized queries, these will all be different entries in QueryStore, and there will be a relatively bigger overhead. I mean, it will still not be that big, but in that case, your workload will also suffer from performance issues such as plan cache bloating and similar stuff. So QueryStore is not ideal for those scenarios, and you will likely hit the QueryStore disk space limit if you have a combinatorial explosion of number of different queries.
So the question is there a cap on the amount of memory that is used, and what happens if it does hit said cap?
Yes, this is one of the great examples where we did a data-driven approach, where we pushed QueryStore first on Azure SQL database, and we figured out, yes, there can be a significant input, and where we introduced these limits. So these limits are relative to the overall memory available to the server. And when this limit is, they're reasonably set, and when this limit is hit, QueryStore temporarily goes into read-only mode until this memory is gradually cleared over time, and this should be pretty fast. But that's a safety mechanism so that the memory does not compromise user database or workload.
All right, I'm going to switch to a demo. If you've got questions, hold on, we'll see if we can answer them, and then if I haven't answered them after the demo, okay? Ask them. So keep it in your head. So I want to take a look at these weight stats, and I'm going to kick off a couple scripts that are going to run to generate just some blocking here in the background while we're looking at the weight stats. So if we just look at our wide world importers database, which you can download from GitHub as an aside, and we look at the QueryStore weight stats, remember I mentioned that those are per plan and they're per interval, or they're over time. So if you look at plan ID 1 here, and it doesn't really matter at the moment what that plan is, but for that particular plan, we've got 6 different weight types based, again, grouped under that category, and we see how long we've been waiting for each of those resources. For plan 2, I'm just waiting on CPU. For plan 3, I've got CPU and buffer IO. So again, in QueryStore, these weights are per plan over time. So if I want to start to look at that in the UI and I come into my resource consumers, I can come in here and I can change this drop-down metric to, instead of being by duration, I can look based on wait time. There's no specific wait report currently, but hopefully that's something that's going to be added in. Now, if I don't want to look at the UI, this one takes a little bit to come back. I do still have the ability to query the system views directly. So if we start with this big old query here, which is just execution information for a particular stored procedure for customer transaction info, right? I mentioned those intervals. Here are those intervals of time. I've got 10-minute intervals set up. So between 8:10 and 8:20, 8:20 and 8:30. And here's the query ID that I have. Here are the different plans that exist for that query. And if I look over here, I can see my execution statistics. I've got duration and IO information as well. Now to put the wait stats information on top of that, it's the exact same query I had before, but now we're also joining over to that wait stats catalog view. And I get a little bit more in terms of rows, because if we start looking at, let's say, this particular plan over time, and we look at the weights for that, we see that we mostly have CPU, buffer IO, a little bit of lock, a little bit of latch. And down here, for the other ones, we're just waiting on CPU. If I come back to the UI and I want to view that information, what we see when we hover over the individual query is we get the wait information in that pop-up that shows up there. Okay? And then the last query that I want to show here, which I think could be potentially really useful, depending on what you've got going on in your system, is let me see what the highest weights have been in the last 5 minutes, 10 minutes, right? I'm just configuring this down here, looking at the last runtime stats interval. So what do we have for the last 10 minutes? That one just gives me parallelism. If I drop this down to something a little bit smaller, what I want to get is my lock weight. Nope. One more try, and then we'll move on. There, we get some variation. So I still don't get my lock weights to show up, which is what I wanted to get, because I'm generating some blocking in the background. But again, I can look at that just for a particular interval of time to see what the top weights are within that particular time. But that's just giving me overall. Right? If I want to drill into something specific like the plan, I've got to go look at the plan. And understand that the wait stats that are captured in QueryStore for a plan, those are different than when you run a query and you get the actual plan and you have wait statistics in that. That's new functionality that's available, but those are two different things. The wait stats in QueryStore, it's basically like we snapshot from session weights at the beginning of the query, we snapshot again at the end, and that information for that query execution is what goes into QueryStore. Did I answer your question? Go for it.
No, the question I had was going back to QueryStore writing to disk. Is there a wait stat for that?
Is there a wait stat for writing the QueryStore data to disk? I think it's a QDS flush or something.
Yeah, I think it is, but it is categorized into unknown because it's fairly insignificant towards the other ones that are actually happening. So we're looking at this from our telemetry, and if we were to see this increase, we would probably do something about it.
Okay, is there also something that tracks the amount of time it's in read-only sync?
Yes, there are X events which we're collecting on SQL Azure, but you can also set up in your database to fully track QueryStore state changes, any events like flushing to disk, started, finished, read-only modes, like everything that we use to see from telemetry is exposed to users as well.
Right. There's somewhere, I don't know the exact count, I want to say it's somewhere around 50 different extended events. Not trace, right? Extended events. That's where you've got to go to grab that information. Yeah.
All queries captured in the QueryStore, or you can control that?
Are all queries captured in the QueryStore? There's a setting that differentiates whether I'm getting all or whether I'm getting most of them except for the ones that are insignificant, the ones that execute one time, the ones that have a really low CPU. That's a setting that you can configure. It's not documented. in terms of what it determines as insignificant, and you don't have the ability to configure it, and SQL Server reserves the right to change that if necessary. So again, that's based on telemetry data that's captured.
But
so do you have the ability to manually archive? You can take data from QueryStore and select it out and store it somewhere else. You set the retention time. And whatever that retention time is, when that gets met, then that data gets pushed out of QueryStore.
yeah, but the settings are data-drivenly set in a way that your important workload, if you choose this, not to capture all queries, but the most relevant ones, that over time that should converge to actually what is relevant for your workload. And also one more, sorry? Okay.
So the question is, can anyone access QueryStore? As a reminder, one of the slides I had in the beginning, right, which said that in order to view the data, you had to have view server state. So you just need to give that login that permission. If you want to force plans, you've got to have DBO. So I want to go on, and I know you've got questions, and I love the questions, but I also want to make sure that I get through my material. So I'm hoping that we're going to have time for group questions at the end. If not, we will stay and answer them. But let me move on to talk about plan forcing. If you have a question, just hold on to it. So plan forcing. How do you fix a query that doesn't perform well? Ideally, let me start with that. How do you ideally fix a query that does not perform well? You tune it, right? You change the code, you change the schema in some way. But let's say that you and your developers don't get along so well. Or let's say, I'm not saying that happens, right? But let's just pretend. Or let's pretend that it's a third-party app and you don't have the ability, no, let's just say that you and your developers don't get along that well and they're not going to change the code right now. What else could you do? You could change it, you could end an index, what else? Hints, like recompile, right? Yeah. I had a gentleman the other day that was talking all about the recompile hints in his code, which there's a cost to that, right? Maybe we're going to get the plan that we want, but there's a cost to putting that recompile on my queries. Every time they execute, they've got to go through compilation or optimization and compilation. Now, there's also one of my favorites, and you don't need to admit to this if this is you, but there's the option to manually get the best plan in cache. Right? You probably know somebody who's created that job that on a regular basis goes and frees a plan or some plans from cache, and then it immediately goes and it runs the store procedure or the query with the value that you want. I feel your pain, sir, I do, right? And then it puts that plan in cache so that that gets used, and you do that on a regular basis, or you have something that looks to see. Okay, that's painful, right? Now, maybe you've tried a plan guide. Those are interesting. I've had challenges sometimes getting those to work. There's different syntax that you need to use. But you now have, with QueryStore, the ability to force a plan. So this is ridiculously easy. And by the way, I believe that this is temporary. Forcing a plan, using a plan guide, throwing a recompile, creating a job, those are all temporary solutions. Your long-term solution is changing the code, right? Addressing the schema. So this is a Band-Aid. This is a temporary solution. It is not, let me force the plan and leave it in place, and 2 years later I go and take a look at it. So you have the ability in QueryStore to find those queries that have multiple plans, and then you can select which query or which plan is most appropriate for your query and force that one. And the forcing is not schema bound. SQL Server does not want your query to fail. And if for some reason it cannot use the plan that you've forced, then it will go through normal optimization and compilation and generate a plan. And you want to monitor for that type of event using extended events. And if the plan is no longer optimal, but it's still possible, QueryStore will continue to use that. So if you've forced a plan and you've got a big change in data or you've got something else going on and that plan is no longer the best plan, you forced it, right? So it's going to keep using it. So if you're forcing, it's not just set it and forget it. It's something that you need to pay attention to over time. So let's take a look at how easy this one is. Oh, I'm still running my blocking scripts. We don't want that to happen. Oh. I'm totally not looking at you because I know this isn't your code. I'll take responsibility for leaving that lousy script running in the background. All right. Not planned at all. Okay, let me get this back in here.
So how many of you did actually use plan forcing for QueryStore? Okay.
All right. So with my failures, once this comes up, I'm going to create a procedure, and we're going to clear out the data that I had in that copy of the database. I'm going to create a procedure that has 2 queries in it. And the first time I run this query, I'm purposefully running it with a recompile on here because this is a parameter-sensitive query, parameter-sensitive store procedure. Both of these queries are sensitive. So if we look at my first query, you see I get a hash match that's fed by a column store index scan and a clustered index scan. And down below for the first, oops, sorry about that, for the first query, the second execution of it, I've got the index scan and seek that feed into a nested loop. So for that first query, I have 2 different plans. Now my second query, I have pretty much the same plan, right? This plan shape here is the same as this plan shape down here. So query 1, 2 different plans. Query 2 just has 1 plan. Now one of the things that happens throughout the day, right, is that data gets added to the system. So we're going to add close to 100,000 rows into this table. And then we're going to run those 2 queries again. And I'm still using with recompile on purpose because I want to see the different plans that I get. So my first plan up here stays the same for that first query. But notice that the second execution of that first query has a different plan. Now I've got an index seek and a key lookup into a nested loop that then feeds into a hash match. So query 1, 3 different plans. Query 2, I have the plan that I saw before, which is up here. And now in the second execution of that, I have a variation of that, which has that same index seek with the key lookup. So query 2 has 2 different plans. And if we come into Management Studio and we look at my top resource consuming queries, and again, I'm putting this into a grid view because it's easier to see, you can see that for one of those queries, I now have plan ID 2, plan ID 6. And for the other one, I have plan ID 1, 3, and 5. So I'm going to be a good DBA, and I'm going to do my analysis, and I'm going to look at this, and I'm going to look at my different plans, and I'd spend time, and I would say, OK, this is the plan that I want to use. So I'm going to highlight it, and I'm going to go force plan. Do I want to force plan 3 for query 1? Yep. That's it. It's that easy. And notice here now that that plan is denoted with the checkbox so that I can look at this and visually immediately know that that is the plan that is forced for this query. Now, if I'm really a good DBA, I probably want to use change control, right? So I know when this happens, so I don't just do that through the UI. So I can also use the stored procedure. So for query ID 2, plan ID 6, let me just make sure that's the right one. Yep, query ID 2, plan ID 6, the T-SQL is right here. And I've got T-SQL to force, and I also have T-SQL to unforce. So now that I have both queries forced with a particular plan, I'm going to run it again, and I'm going to run it with the recompile, which is not ideal. If you're forcing plans, there's no reason for you to have a recompile on there. But if I do this and I look at the actual plan, you'll see that now I've got the plans that I forced. I have the same plan for both queries for both executions, right? Now, how do I know that it's forced? The only way I know for certain is when I go into the actual plan and I go into the properties. I hit F4 there. And one of the things that you'll see down here is use plan equals true. So here, when I look in the actual plan, that's how I know that that forced plan is the one that's being used. Now, plan forcing, again, temporary solution. And there are situations where plan forcing will fail. Anybody have any guesses as to what they might be? Drop the index. Yes. If I drop the index, Obviously, that index isn't there. If it's part of the plan, it can't use that plan. So it's going to go ahead and go through compilation, optimization, generate an appropriate plan. Yeah. If it's not using the plan that's forced, it's not going to say anything. You're not going to see use plan at all. If I look at that.
You will see through QueryStore view, QueryStore query, or QueryStore plan, you will see that the plan forcing failed, and you will see the forcing failed reason, which is like index dropped or.
Right. And you can also use my favorite, extended events, to track failures as well. Yeah.
So after 30 days when you set stuff up to put on QueryStore,
Yep.
No.
Right. So the question is, I've set up my retention mode so that data is going to get aged out after 30 days. But I forced a plan. Forced plans, that's not going to go out. So as long as a plan is forced, that query, that plan, that information is going to stay in there. And it's stored within the QueryStore view for the plan. Yep.
what happens if you drop and recreate the procedure?
Ah, that's a brilliant question. What happens if I drop and then I recreate the procedure? Anybody know? What happens? What? So the information is still going to stay there, right? If I drop a stored procedure, because I'm going to change one query, I'm going to add a column. So I drop my stored procedure and I create it. When I drop and create, I lose the object ID and I get a new object ID. So in QueryStore, you've seen in the UI, when we've looked at this, that you've seen what the object name is, right? Object ID, object name, because the query is tied to that. So if I do a drop, my forcing technically is still there, but I'm not running that query anymore according to QueryStore because it creates a new query ID, it associates that with the new object ID, and you're off and running. So when you're making changes, you have to use an alter. You have to use an alter if you're doing forcing. And you need to be very careful. I had a customer that did an alter, and somehow there was a space that got added into a query. And that query, textual matching is in effect, so now that query had a new ID, so all of a sudden it was no longer forced. And you can't just say, oh, for this query, I want this plan over here. This query is close enough, I want to force this query for this plan for this query. No, you have to get that query to execute the plan that you want in order to force it for that particular query. Yeah.
So we're dealing with some issues with cardinality estimator.
Uh-huh.
And we're seeing drastically different, plans for the old estimator versus the new. Would you recommend query enhancement in that situation to resolve that scenario, or would you force a plan, kind of the old plan with the old estimator, force the new plan, I guess, with the new estimator?
So your question is, let's say that you were on 2012, right? You upgraded to 2016. When you upgraded to 2016, your compat mode, let's say that you did set the new compat mode, but when you went to the new legacy, when you went to the new estimator, right, because that's a database scoped setting now, when you use the new CE, query performance is not good. So you go legacy cardinality estimator true, and you get the performance that you want, right, for certain queries. Now for some query, maybe that's only 4 or 5 queries that aren't performing well. Maybe the rest of your workload is the same or better. So your options are, I could either run everything old and leave it old, or I could run new, and then for those 5 problem queries, what do? You could edit the queries, right, to put the trace flag on to use the old CE, but that's a code change. And if you have that ability, okay, but if you don't have that ability, then you can force the plan. And even then use the new CE for all those other queries, but it will force the old plan which was created with the old CE.
So CE5 helps us with that problem.
Cumulative update 5? Okay. Yep.
Are there other reasons other than schema changes that will prevent you from forcing a plan? So for example, if you can't get a memory grant that plan is asking for, will it not force the plan?
Ooh, that's a good question.
So maybe that one particular time, but the next time it will succeed. So plan forcing beneath actually does use plan hint. So it's a hint to the optimizer to actually prioritize this plan, to skip all the optimization costing, and to try to use that plan if possible, but that's not a guarantee.
Right, because in the end, it doesn't want your plan to, it doesn't want your query to fail. So his question, which I didn't repeat initially, I apologize, is that if I have a forced plan and I go to run that query and it can't get the memory grant needed for that plan, what will it do? Right, and at that point, it could go ahead and it could go through normal compilation and optimization and not use the forced plan in that scenario. Yep.
Sometimes in the top right graph, there's circles, and sometimes there's squares or different sizes and colors.
Yep. So sometimes when you're looking at data in this graph, the circles are different sizes. Sometimes you see squares. The colors are just to denote the different ones. So you can look at the same query in 3 different panes and you'll get different colors. That doesn't matter. The sizes are going to be respected to the volume, right, of data that's captured for the runtime stats. When you see something that's not a circle, it's because of interrupted execution. So remember that I have the plan and the text being sent to QueryStore, and then after the fact, the runtime stats come along, right? So if I execute a query and I get a plan over here, and that query's running and running, and somebody goes in and kills it, I don't have runtime stats for that plan. So that shows up, and actually you can see that on the underlying views as execution type. 0, 2, or 3 are the options. 0 means it's successful, which is what you see with the circles. Triangles and squares means that the execution was interrupted.
So yeah, QueryStore tracks statistics also for queries that were compiled and interrupted during execution, either to some error, timeout, canceled, whatever. So those are really convenient for your troubleshooting.
Right. One more. Yep.
Is there a way to see what plan has been forced?
Is there a way to see which plan has been forced? There's this lovely view that I really like, which is why I want you to be on 17x of Management Studio, which is queries with forced plans. Now, you can also query the views directly, but this UI tells me which ones are forced. And this is important if you're doing anything like a backup and restore into dev or test, and you're running into an issue in production and you're trying to recreate it in your test or dev environment. You want to make sure that whatever you have in production in terms of forcing, right, is consistent within test or dev so that you're testing the same thing, because otherwise you could waste a lot of time, right, spinning your wheels if you've got different forcing between production and test or dev. All right. So now we get to automatic plan correction, which was new in SQL Server 2017. And it falls under automatic tuning. So automatic tuning is a phrase that you've heard a little bit. And within automatic tuning, we have plan correction and we have index management. So plan correction is currently in SQL Server 2017, and it's in Azure SQL Database. It is not enabled by default. But what both of these do is they're monitoring the workload, and then they're implementing changes for you, if you want, based upon changes within the workload. So when we talk about automatic plan correction, what we're looking at is something that you're setting per database, and you will note that it is Enterprise Edition, and it's also available in Azure SQL Database, regardless of the tier. You've got to have QueryStore running because it's using that QueryStore data underneath, right, to determine what changes have occurred. There is a DMV, DMDB tuning recommendations. If you want to capture that information but not have it automatically change plans for you, you can do that, and you can look to see what it puts in DMDB tuning recommendations and then implement that forcing manually. The idea is that you don't have to sit there and monitor the system all the time and figure out what needs to be changed. You don't have to figure out how to correct that problem. It's going to address that issue for you automatically. So it's cyclical, right? If we start at the top, if there's a change in a plan, it's going to compare performance. And it's going to look to see, is there a regression in performance? Did performance get worse? And if it did, if it regressed, then we can force the last known good plan. Once it's forced that last known good plan, then monitor. Let me make sure that that plan is still good. And if it is not good, if there is a recompile, either a stats or a schema change that causes a recompile, or if there's failed forcing for some reason, then it will unforce that query, or unforce that plan for that query. And then it continues to go through that process. So I'm going to show you how that works, not quite as fast as what went through this morning, but with the same idea in play. So we're going to take a query that's parameter sensitive. Let me open this up. And I've already restored the database. And if we look at this database in terms of what we have currently for forcing, this is set to off. So right now we're not doing anything. And I'm going to go ahead and change that with this. Alter database, set automatic tuning, force last good plan on. And so if we check our tuning options again, right, you see that this is enabled. So now we're going to go ahead and run some queries externally that are going to create a little bit of a workload. So all we're running is a stored procedure that we had created earlier, the customer transaction. And this is our one that's parameter sensitive. So I've got this going. And let me switch over to that database so we can see what we have for our plan. So here's that query. And we have to start an index seek with a key lookup, right? Let's see how many times we have in terms of our execution. What do we got? It's executed about 3,500 times at this point. So I'm going to stop that one. And then I'm going to introduce the regression. So right now, we just have that plan. And I come in here. This starts running. And you'll notice that now I have this selected, and I have an additional plan here. And I'm looking at duration. If I actually look at CPU, right, we'll see that the newer plan, which is a clustered index scan, so if I highlight this plan, right, that query regress. So rather than my nested loop with the key lookup, now all of a sudden we went to an index scan. Automatic tuning picked that up and said performance was worse. I'm going to go ahead and force that last known good plan, and it did that automatically. If we look within tuning recommendations, right, you'll see there's an entry in here. CPU time changed from 13 to 159. So that exceeded the threshold in terms of what defines a regression. And so then it went and forced the last plan. Now, what happens if I realize, well, gee, it's forcing this key lookup here. And if I look at this plan, there's an index recommendation. Right? Now, we don't just go and create index recommendations all the time. Right? We do a little bit of research. Indexing is an art and a science, but let's say that, you know what, this is an index that I want to create. So if I come back over here, and I'm going to go ahead and create that index, and I come back, and I refresh, it's no longer forced, right? It detected schema change, index added, new plan is in effect, because that plan, which was forced, is not going to be used anymore. I've got a schema change, new plan comes in, it's the plan that uses that new index that I created, and assuming that's stable going forward and I don't have any other plans, that's what it's going to continue to use. Yeah. Is this true if I manually force a plan? No, this is the automatic. This is automatic tuning, right? So automatic tuning means I'm going to let SQL Server use data to determine, right, data-driven approach here. Let me use this data to determine if a query has regressed, and if so, I'm going to force it. And then it's going to continue to monitor, right? Is that ideal? In this case, I forced a schema change, so it unforced. But that, if you're forcing manually, it's not going to do that. Yes?
In your examples, you had one procedure with different execution plans. Why would the SQL Server decide to make a new execution plan if the schema hasn't changed?
So the question is, in my example, I had a query, and it had two different plans. And so why on earth, if I had a plan, why would it suddenly use a different plan? If I restarted the instance, and the first time that query executed, it used different input parameters that caused a different plan. If I had enough data change, modify, that it introduced a stats update. If I have a stored procedure that has temp tables, right? Temp tables are prone to recompilation in certain scenarios more frequently. So there's a host of reasons why a recompile might occur for a query. And then depending on how that query gets executed after that, there could be a different plan that gets generated. Yeah, Hugo.
When I look at issues, what I often see is a plan that executes in either 40 milliseconds or 10 minutes, and another plan that takes 200 milliseconds across the board. When it does more than 1,000 times in each interval, you look at averages,
So your question is, you've got a scenario where you've got a query that has different plans. One of those plans sometimes executes in 10 milliseconds, 40 milliseconds. Sometimes it executes in 10 minutes with that particular plan. And then you have another plan which executes always in approximately 200 milliseconds. So your question is, you would force the 200 millisecond plan. Do you want to answer it?
So yeah, like within internal algorithm that determines whether one plan is better than the other, we will take into account both the average over time and standard deviation. So that should help with your example.
And that's captured also within QueryStore, your average, your standard deviation. So when you're forcing a plan, that plan was compiled with the original input parameters, right? And that's the plan that gets used. That's the plan that gets used. If I force a query, if I force the plan for the query, that's what gets used, regardless of what I input, because I forced it. It's not saying, oh, this one's good for 6, 7, 8, and 9. I'm going to use that, but not for 10. No, I forced it. That's the one I'm going to use. Right. I forced that plan for the query. That's what it's going to use, which is why it's a temporary solution.
Yes.
Yes. Is automatic tuning using force plans? Yes. That's why you have to have QueryStore enabled. It's using that same functionality.
But it does use the same mechanism to enforce the plan, but it does have additional parts like detection and validation afterwards. They're both automatic, and this is something that is not part of manual plan forcing, right? This is what user does manually. It looks at QueryStore data. It looks at, yeah.
Yes. So the question is, if I've got a multi-tenant environment where I have thousands of different databases that serve thousands of different customers, but the schema for those databases is the same, the queries that execute that are the same, I've got QueryStore enabled. Can I just take QueryStore from one and drop it into another?
Currently, no, but you can enable QueryStore in each of those databases. And if your question is, how do I enforce the same plan across all databases, like auto-tuning should help you with that. But if you want manual plan forcing, you can correlate those different plans, even though they will have different IDs. You can correlate by using query hash and plan hash, which should be uniformly the same.
Right. So QueryStore is capturing the query plan hash and the query hash, right? So you can use that to find the similar ones across, because obviously your IDs are going to be different. Yeah. But no, there's no way to export and whatever. There's no way to like force it to work. Yeah. How about consolidating that information? Meaning across multiple databases or across instances? Right now, that's a roll your own option. Right? There's no automatic feature that's going to pull all that information together for you, but that's something that you have the ability to do because that underlying data is exposed through the system views. So when you do that, feel free to email me and I'll link to your blog post and show how you do it. All right, so this is the other question that I frequently get when I'm talking about this. Can I trust it? Right? You want me to go do what in my production database? And you're torn, right? Because as a DBA, you want your time back, right? You're tired of firefighting. The idea of letting something else manage these problems for you is pretty appealing. But you're also a DBA, so you got this whole trust but verify thing going on, right? I get it. It's developed with a lot of telemetry. Again, 2 million databases in Azure SQL Database. It isn't perfect, nothing is, but it's a really good starting point in terms of making your life and getting some time back into your life a little bit better. It catches severe regressions, and the ability to recover from a less than ideal situation is one of its big strong points, in my opinion. If you're not certain, you've got QueryStore, you're going to capture that information in the DMV, look at the DMV on a regular basis, see what information it's capturing, go look at those plans and figure out, is that something that I would force? Maybe you're going to find scenarios where you should be forcing that you didn't even know about because you can improve performance. Right? So if you're not certain, I'd recommend starting with that.
Yeah, and I would just add that as it's put here, we've put numerous mechanisms to recover from any bad decisions, and each of them obviously is not perfect and has some slight probability that it fails. But the thing is that there's multiple of them continuously applied, so when you multiply those probabilities, like the overall probability of making a bad decision and persisting with it should be really, really slow.
All right, so we flew through a lot in 75 minutes. We talked about QueryStore, understanding at the basic level what it is. We talked about the weight stats, how to force, and we just touched on forcing, and again on automatic tuning. If you've got additional questions, we're happy to answer them. There's a few resources available out on Pluralsight. I'm currently working on a course on automatic tuning. If you're interested in exporting the QueryStore tables, there's a connect item for that as well. Please remember to fill out your session evaluation. Yeah. Oh, you want to take a screenshot of that? Right. Please remember to make sure to complete your session evaluation by next Friday at the very latest, hopefully earlier. If you've got questions, we're definitely happy to answer them. Otherwise, if you're here for Bob Ward's session and you sat through this just so you had a spot for Bob Ward's, thanks for hanging with us. Bob's coming up next. Have a great day.